I'm not even sure about how to pronounce this name, but I'll call you Rahim for now. Hi, welcome back to another past paper walkthrough video. This is OCR MEI Core 2. If you're not doing MEI, then do not watch this video because it will waste your time. And this video is suggested by Rahim. And as every single paper of MEI course, it's an hour and 30 minutes with 72 mark as the full mark. So let's head right on to section A. So section A part 1, question 1 part 1 is differentiate 12 cube root of x, and part 2 is integrate 6 over x cubed. So question 1 is again a very straightforward integration and differentiation question. Part 1, what you would like to do is to put everything into power form. So it is a 12x to the third, because cube root is 1/3. And when you differentiate this, you drop the power and subtract the power by 1, which is 1/3 of 12 x to the power of minus 2/3. And this cancel out to 4, and therefore the answer is 4x to the minus 2/3. For part 2, you need to integrate this expression, and once again what you would need to do is to add, make it so that it is in the form of a power. So it is a 6x to the minus 3 instead of a fraction. So you integrate that by dx, and you will get 6x minus 3 plus 1 is minus 2, and divide the whole thing by the increased power, which is minus 2. And remember to add c, because you have a constant there somewhere that can be 0 or something else, so you must put plus c. And everything cancels to 3, and therefore it is a negative 3x to the minus 2 plus c. Question 2 is a sequence is defined by u1 equals 2 and uk plus 1 is equal to 10 over uk squared. And you have to calculate the sum to the first 4 numbers of u. Okay, so this question 2 looks absolutely horrible because it is a combination of a sum to sequence with a sequence notation, which is very unusual, and therefore we need to kind of simplify or decode this whole question. So the first thing is this is a sum to 4, so do not overcomplicate things by trying to find a general solution to this sum of sequence, because you won't find it. And sum to 4 is relatively easy because you just need to find u1 plus u2 plus u3 plus u4. That's it. That's all you need. And the only way you can do this is to find out u1, u2, u3, and u4. So u1 is given as 2. Now u2, how do we find that? Because uk plus 1 is equal to 10 divided by the previous number to the power 2. We know that u2 is 10 over u1 squared, which is 2 squared, which is 10 over 4, so that is 5 over 2. Now we need to find u3, and once again you can do the same thing. So it is 10 over 5 over 2 squared And because 5 over 2 squared is 25 over 4, and this is a 10 divided by this fraction, you flip the bottom fraction up, so you get 40 over 25, and you can simplify that to 8 over 5. This is U3, and finally the most complicated one, U4, because as you go along the fraction get, well, the magnitude of the fraction is relatively stable, but the numbers get really large on top and bottom. So take care when you're doing calculations. So 10 divided by 8 divided by 5 squared, that is 10 multiplied by 25 over 64, and you should get 250 over 64. And after simplifying, you should get 125 over 32. Now we have the 4 values, and all we need to do is to sum them all up. So if you put them all into the calculator, you should get the correct answer to be 1061 by 160. So this is the answer to this question, and if you understand what the question asks, it's not all that bad. But if you do not understand the notations, then these 3 marks will be really difficult to get. Now we have question 3. An arithmetic progression has 10th term 11.1 and 50th term 7.1. Find the first term and the common difference. Find also the sum of the first 50 terms of the progression. So for question 3, it is a just arithmetic sequence sum. So we know that a plus 10 minus 1 difference is equal to 11.1, and also we know that a plus 50 minus 1d is 7.1, derived from just a simple equation of general equation of arithmetic progressions. Now we can subtract the first equation by the second one to get that 4 is equal to minus 40d after you've simplified all the brackets, and a minus a is just nothing, so it's just minus 40d. Now we can divide both sides by minus 40 to get that d is minus 0.1 or minus 1 over 10. And now we can just substitute this d back into the first equation to get that a is equal to 11.1 plus 9 times 0.1, which conveniently is just a whole number 12. So that's the first part that we need to do. Now the second part is a bit more tricky because we need to find the sum. So the equation is a plus n minus 1d sum to 50 from 1. Now this sigma can break into this whole expression, but first let's break open this bracket as well. So the sigma of a plus nd minus d, and after you've broken the sigma into this whole expression, you get that it is the sigma to 50 of a minus the sigma to 50 of d plus sigma to 50 of nd. And because a and d are both static whole numbers, constants, we can just make it so that sigma of 50a is just 50 lots of a. Same goes for 50d minus 50d. Now this part, nd, because d is a multiple of n, we can factorize the whole thing. Factorize the sigma to d sigma 50 of n. And the sigma 50 of n is just the first term, which is 1, plus the last term, which is n, all multiplied by n over 2. Now, this whole expression, because n is 50, we are summing from 1 to 50. This expression will be 51 times 25. And we need to multiply this whole thing by the difference, which is 0.1 minus 0.1. And this is at 50 lots of 0.1, which is 5. And 50a is 50 12, which is 600. Now this is 605, subtract by 51 times 25, and if I use my calculator, you get 2550 divided by 2 times 0.1. It's just because it is decimal, so that it is in divide by 2 form. And because this is multiplied by 0.1, you can cancel out the 0, and you get 605 subtract by 255 over 2. And if you put it into calculator, you get 477.5. And that's the answer for this question. For question 4, it is a radian question with a sector of a circle. So we are finding the perimeter of this sector with angle 1.5 radians and area of 27 centimeters squared. So first step, set your calculator to radian mode, because I've seen people not doing that and getting some ridiculous answers. And second, we know that the area in radian form of a sector is just half r squared theta. And therefore, we can just calculate r using this whole equation. So 27 times a half of r squared 1.5. And you can just rearrange all that. So 27 times 2 divided by 1.5 is 36. So r is 6. Technically it's plus and minus 6, but r have to be positive because there are no negative distance, and therefore we get r is 6. Now we want to find the area of a sector. So a sector have 3 parts to it: 2 radii and a distance. And the distance s is defined as r theta. And this is the definition of a radian, is when there is 1 radian, s is equal to r. So we know that the perimeter is 2 radii plus s, which is r theta, where theta is 1.5. So that is 6 times 2 is 12 plus 1.5 times 6, which is 9. And so the answer of this question is just 21 centimeters. For question 5, use calculus to find the set of values of x for it which x cubed minus 6x is an increasing function. So the definition of an increasing function is when x increases, y increases, which means that the gradient is positive. So using calculus, we know that dy by dx is equal to 3x squared minus 6. And when this is an increasing function, dy by dx is greater than 0 because it's positive. And therefore, if we put this in, combine these two equations, we get that we have to have 3x squared minus 6 to be greater than 0. And by rearranging, we get that 6 is smaller than 3x squared, and dividing by 3, we get x squared is larger than 2. And therefore, x have to be greater than plus or minus 2. In this case, this notation is not the best notation, and therefore we have to just make it so that it is two different it is the square root of 2 rather. Make it so that it is a combination of two inequalities. So first of all, take positive root 2. When x is larger than positive root 2, on a graph, it would look sort of like this. So x root 2 x. Okay, so when x is larger than positive root 2, it is everything to this side. And in this case of x is larger than minus root 2, what it really means is that the magnitude of this inequality is larger than root 2. And therefore the magnitude is to the left of negative numbers and to the right of positive numbers. So the inequalities are x larger than root 2 and x smaller than minus root 2. Question 6, part 1. On the same axis, sketch the curve y equals 3 to the power x and y equals 3 to the power of 2x, identifying clearly which is which. And part 2, given that 3 to the power 2x is 729, find in either order the values of 3 to the power x and 3. For part 1, the first thing you should note is that these are exponential functions, and therefore it never ever reaches 0 and negative. So for incredibly negative x values, both of these equations approaches 0, but never quite reaches. And for x is 0, both of these are 3 to the power 0, which is 1. So they both crosses 1. Now how do they differ is when x is a large positive number. So if y is 3 to the power 2x, it will be greater than y equals 3 to the x, when x is a large positive number. And so it would appear that there are two spots, one of which is y to the one of which will be 3 to the 2x and 3 to the x. The 3 to the x will be smaller than 3 to the 2x. And for negative numbers, however, this effect reversed. So for low values of for large negative values of x, the bottom 3 to the power 2x will appear smaller than 3 to the x, and therefore the bottom curve on the left joins with the top of the right, and because they both crosses 1, we know that they intersect at 1 and cross over at 1. And so it is an exponential curve. Excuse my poor drawing on this computer, but this should be sort of the curve the examiner wants. So make sure you clearly cross the two lines and make sure that they meet at y equals 1, x equals 0. Okay, so what this question really wants for part 2 is that you should use log to help you answer this question. So if you log both sides, we get that log base 10 of 3 2x is equal to the log base 10 of 7 to 9. And because of log rules, we can drop the power to the coefficient of the log without a problem. So that is 2x lots of log, not natural log, which is another log of 3, and log base 10 of 729. Now we can divide both sides by log base 10 of 3 to get 2x by its own. So we have log base 10 of 7 to 9 divided by log base 10 of 3. Now you need your calculator for this. So log of 7 to 9 divided by the log of 3 is just 6. And therefore 2x is 6. And so x is 3. So because x is 3, 3 to the x must equal to 27. And that's the answer for question 6. So question 7 involves some trigonometry where you need to show the equation sine squared x equals to 3 cos x minus 2 can be expressed as a quadratic equation of cos, and solve the equation for x between 0 and 2 pi. Okay, so once again, switch your calculator to radian mode if you changed to degree mode for some particular reason. So we need to convert this into a cos equation. So we need to convert sine squared x to something in the terms of cos. And luckily we have an identity, which is sine squared theta plus cos squared theta equals to 1, and therefore sine squared x must be equal to 1 minus cos squared x. So 1 minus cos squared x is equal to 3 cos x minus 2. And by rearranging everything to the right, we get that cos squared x plus 3 cos x is equal, 0 equals cos squared x plus 3 cos x minus 3. That's what I meant. Now, can we factorize this, or can we not? It appears not easily at least, so let's go for quadratic equation. So, because cos squared x is just cos x squared, we can put it so that cos x using the quadratic formula is minus b, 3, this is minus 3 because it's positive there, plus or minus the square root of b squared, which is 9 minus 4 ac, because a is 1, c is a negative 3, so minus 4 ac will be plus 12, or divided by 2a, which is 1. So cos x is minus 3 plus or minus square root of 21 divided by 2. Now this lot have two values, so let's have a look. So if we do minus 3 subtract by the square root of 21, we get minus 7 point something. Where's my cursor? Here it is. So we get minus 7.58 over 2, which is the magnitude of it is way greater than plus or minus 1, which out of a cos function cannot exist, and therefore minus 3 minus square root of 21 over 2 is not valid, and therefore we can ignore this part and just focus on minus 3 plus root 21 over 2. Now minus 3 plus root of 21 in this case is 1.58, which is when divided by 2 is less than the magnitude is less than 1, and therefore this whole number will equal to 0.79129 rounded. And because this is cos x, we can do arccos, which is the reverse function of cos, to get that x is equal to 0.65788, or in 3SF 0.658 radians, denoted by a C on the top right. Note that this is a cosine function, and if you plot the cosine graph, or if you do the whatever method it is, you know that there are two solutions to this answer, to this question, because we are currently starting with 0.79, and therefore from 0.79 draw a horizontal line, we get 2 points. Now how do we find the other one? Because this is 0.58, which is definitely this point right here. We need to find 2 pi subtract by whatever we got from the original one, because this is a mirror image, and therefore we subtract by 0.658, and that will be 2 pi subtract by that will get you 5.6253, which rounding to 3SF is 5.63 radians. So these are the two answers that you should be getting. Finally, the last question of section A, question 8. Show the graph, well, the following shows the graph of log 10 of y against log 10 of x, and it is a straight line through 2, 8, and 0, 2. Find the equation relating log 10 of y and log 10 of x, and hence find the equation relating y and x. Once again, this question is a bit different to what you're used to, but it's doable. So start off by looking at this equation. You can definitely see it is a straight line, so y is equal to mx plus c should pop into mind. But on the y-axis, we have log base 10 of y, which is log of y, and mx will be log of x plus c, of course. Now we need to find the relationship between log y and log x, so we need to find m and c. Luckily, the graph shows us everything. C is 2 because it's the y-intercept, so that's straightforward. M is the gradient, which is the difference of x divided by the difference of y divided by difference of x, which is 8 minus 2, which is 6, divided by 2 minus 0, which is 2, so m is 3. So now that we have these information in mind, we know that log of y is equal to 3 log of x plus 2. So that is the first part of our answer, and we need to find the normal relationship between y and x now. So first step is, because we want to take take 10 to the power on both sides, the only thing stopping us doing that is this 3. It makes it a lot more complicated. So we use the log rule, move the 3 to the power, which means that it is now log of x cubed plus 2 equals to log y. And now we can take the power of 10, so it is 10 to the log y, which is just y, because 10 to the power cancels out log base 10. Same goes for this side, although but note that there is a plus 2 here, so it is a 10 to the power of log x cubed plus 2, and by exponential rules or power laws, 10 log of x cubed plus 2 can be written as multiplied, the front bit multiplied by 10 to the 2, because multiplying two powers add them up. And now the 10 and the log goes away, so that you get x cubed times 10 squared equals to y, and therefore y is equal to 100 x cubed. So that's it for section B, section A. And this concludes this video of section A. If you want to learn how to do section B, I'll be putting the walkthrough sometime in the future, in the short future. And overall, this section A is quite a tricky section A because of really different and special notation and wordings. But if you understand these wordings, all the steps that you need to do are relatively straightforward and should not pose any kind of difficulty. So thank you very much for watching, and I will see you on the next one.